All right, so question number 3 says a student builds this electric circuit to measure the temperature of a room. This is the circuit that is given. At 20 degrees Celsius, the voltage across the thermistor, this is the thermistor, the voltage across the thermistor is 3.9 volt. Explain why the reading on the voltmeter is 2.1. So the reading here is 2.1 volt. As you can see, this is a series circuit, right? So in a series circuit, the current is always the same at all places in the circuit. So the current is, if for example, the current is X, the current will be X here, 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 and here. It does not change. But if we're talking about the voltage is always shared among the components. But even if it's shared among the components, for example, here are two components, a thermistor and a fixed resistor. So it will be shared among these two. But the total voltage, when you sum up the total voltage, it will always be equal to the EMF. So whatever the EMF is, for example, here it is 6 volt. This 6 volt is shared among these two components. But when you add up the voltages, it will always be again 6 volt. And they have already mentioned that the thermistor has a voltage of 3.9 volt, which means the rest share of the 6 volt belongs to the fixed resistor. So if this is 3.9, this should be 6 minus 3.9, which is equal to 2.1 volt. This is what we are going to write here. So what we're going to write is the components are connected in series, so the potential difference is divided among the two components. The potential difference of the two components must then always add up to 6 volt again. Since the PD across the resistor, across the thermistor, actually, I wrote it wrong. Across the thermistor is 3.9 volt. The PD across the fixed resistor is 6 minus 3.9, which is 2.1 volt. And 2.1 volt basically is the voltmeter that is across this fixed resistor. Okay. The next question asks for a calculation. The resistor in the circuit has a resistance of 290 ohm. Calculate the current in the resistor. We are asked to find the current in the resistor. So the formula is already given. I just have to rearrange the formula. So current is equals to voltage divided by resistance, right? Now, voltage, as we are asked for resistor, the fixed resistor, we have to take the voltage of the resistor. What was the voltage of the resistor? It was given, it was 2.1 volt. So it's 2.1 divided by, the resistance is 290. If you divide the two, you get an answer of 0.0072 ampere. Now they're asking, state the reading on the ammeter. So the ammeter is placed here. We found the current across this, which was 0.0072. And at the beginning, I have already told you that in a series circuit, the current is same at all places, which means if the current here is 0.0072, the current here at the ammeter will also be 0.0072. So it will be the same reading, 0.0072. Calculate the resistance of the thermistor. It's going to be the same, right? So V equals to IR, R equals to V by I. Now, the current is same everywhere. So for the thermistor, the current is also 0.0072. But the voltage across the thermistor was 3.9. So we're going to use 3.9 here. Now, if you place this in your calculator, you're going to get an answer of 540 ohm. That's the student observes that the voltmeter reading increases as the temperature of the room increases. Explain this observation. All right, so if you go to the circuit, they said that if the temperature increases, then the voltmeter reading is also increasing, and we have to justify why. The thing is, we have a thermistor here, right? And normal components and thermistors do not behave the same way. By normal component, I meant filament bulbs. So filament bulbs and thermistors do not behave in the same way. If we give a little background check, thermistors are actually made of semiconductors, okay? So in semiconductors, which means in thermistors, if you increase the temperature, normally we know that if temperature increases, then resistance also increases, right? Because particles start to collide more and stuff. But for a thermistor, if the temperature increases, the resistance actually decreases. Now, why does it happen? We can get a little background check. In semiconductors or in thermistors, as temperature increases, the atoms inside the thermistors release electrons. So electrons basically gets knocked off from the atoms. So it's releasing electrons. What are electrons? Electrons are negatively charged particles. And what do we know? We know that the more the charges, the more the current, because the flow of charge is equal to current, right? So as they're releasing more electrons, it means that current is increasing, or flow of electrons increases means that the current is increasing. If current increases, it means that resistance decreases. All right, now our main part is this current increase. So as the temperature increases, the thermistor causes release of electrons, which causes an increase in current. Now, what do we know? That this current in the series circuit is same everywhere. So if the current increases, it increases for the entire circuit, right? So the current is increasing. Now, fixed resistor, across the fixed resistor, the resistance is same, right? Resistance is constant. Now, according to V equals IR, if resistance is constant, which is 290, but current has increased, right? So for example, current probably before it was 2, now it's 4, which means that the voltage has also increased, right? As the current increases, the voltage increases. So provided that resistance remains the same. So our voltmeter is across this fixed resistor. So if the voltage of the fixed resistor increases, the reading on the voltmeter also increases. So we're going to write that. What do we have here? We have that as temperature increases, the resistance of the thermistor decreases. So the total resistance of the circuit decreases. This causes the current in the circuit to increase. The resistance of the fixed resistor remains constant. So using V equals IR, an increase in current causes the PD across the fixed resistor to increase, which means that the voltmeter reading also increases. Hopefully this makes sense. Number C, it's 2, B2. The student wants to use the circuit as a temperature measuring device. They have this additional equipment, a large beaker, okay, water at different temperatures, a thermometer. Okay, they have water at different temperatures and a thermometer. Now we need to describe what measurements the student needs to take so that the circuit could be used as a temperature measuring device. Assume that the thermistor is in the circuit is waterproof. You may draw a diagram to help your answer. All right, let me go back to the circuit. Okay, it's actually pretty easy because you don't have to know any concept for this. You just have to write an experiment on how they can determine the voltage. What can we do? They have already told you that they have water in beakers at different temperatures. So you can dip this particular thermistor inside the beaker of water, right? And then you can place a thermometer here, right? We have placed a thermometer. Now we have different beakers of water of different temperatures. So after you place it at different temperature, what we are going to do is we are going to measure the temperature. For example, now the temperature is 50 degrees Celsius, okay? Now, for this 50 degrees Celsius, you're going to measure the corresponding voltage with the voltmeter. So now we have the voltage for a particular temperature. We're going to record this in a table and then we can plot a graph of voltmeter against temperature, right? And then you can use that graph to determine the temperature for any given voltmeter reading. For example, if you have a graph like this of voltmeter against temperature, and for example, at 10 degrees Celsius, you have a voltage of 2. At 20, you have a voltage of 4. At 30, you have a voltage of 6, right? And you draw a graph of it. Now, if you want to know what is the voltmeter reading at 15 degrees Celsius, you can find 15 here and you can just place some dotted lines and then you can find the corresponding voltage, right? So if we plot a graph of temperature against voltage, we can also find different voltages for different temperatures according to the graph data. That's what we are going to write here. All right, what did I write? Place the thermistor and a thermometer in a beaker of water. Heat or cool the water so that the temperature of the thermistor changes. Measure the voltmeter reading for a range of different temperatures and then plot a graph. Plot a graph of voltmeter against temperature, which will help you to determine the voltmeter reading at any given temperature. Now, about the drawing, what we can do is we already have the circuit, right? Let me see the circuit once. Yeah, all right. So we have a beaker, and I'm thinking of tilting the circuit a little so that I can have the perfect orientation. So this is my thermistor. Oh, sorry, thermistor, and then my fixed resistor with my voltmeter, right? Yeah, done. And this is the beaker of water. Water at a particular temperature. We also have to add a thermometer. Done. Oh, we are done with question 3.